Hi guys, this is Mrs. Gassler, and in this video we're going to talk about eyeglasses, which is an application of lenses that we're talking about right now with refraction. So I've got some partially prepared notes that you can follow along with. They're not very long, there's not a whole lot to talk about with eyeglasses, it's just a special use of that lens equation. Alright, so when we talk about eyeglasses, there are two kinds of scenarios that a person would need eyeglasses for. If your eye is normal, when light comes in, it focuses on the back of your eyeball called the retina. If you need glasses, it's because your eyes don't focus on that spot. If you are farsighted, first off, farsighted people are the ones that can see can see far away, but not up close. These kind of people usually need reading glasses. These are the people that have a hard time reading things. And what's happening is that the light is focusing back behind the retina, so that's no good. Right there, it focuses behind where it should be. So when they put a lens on here, it is a converging lens, which is the convex type lens, and that helps to focus the light a little bit closer in, so that when it focuses in the eye, it hits on the back. Okay, so make a note there, it's the converging lens that we need, because it makes it focus a little bit closer. Okay, so the nearsighted people can see close, but not far away. Okay, they can see close but not far away. A lot of people are nearsighted. People who wear glasses regularly tend to be nearsighted. Farsighted people tend to only wear their glasses when they're reading. So nearsighted is the opposite. So instead of the light focusing at the retina or behind, it focuses in front. So these lines cross before they get to the retina. So that's no good there either. So what we need to do here is we need to get that light to be spread out a little bit further. So this uses a diverging lens, which is the concave lens, so that when the light comes in, it then can focus on the back of the eye where it's supposed to. Okay, diverging, converging. So if you feel a person's glasses, you might be able to tell by looking at that. So when we talk about glasses, and you might hear this if you ever go to the eye doctor and get a pair of glasses, they'll talk about the power of your lenses, and that tells you about the strength of the lens. Okay. Sometimes your eyes, if you wear a pair of glasses, you may not have the same power in both eyes. I know I don't, but we'll talk about one of those later. And there's two ways that you can think about the power. First off, it's the 1 over the focal length of the glasses. And it's measured in diopters. Diopters is the unit that they measure, and it's 1 over a meter. 1 over a meter. That's all. So we've got the focal length here. So being 1 over meters. 1 over meters. That's a thing. You're going to have to convert centimeters to be able to use the centimeters in here. So we've got 1 over meters. Okay, and then this is the focal length of the lens. Focal length. Okay. Another way you can think about power is to talk about the distances of the objects. And so we've got your object, the distance of the object that you can see with glasses, minus the distance of the object that you can see without your glasses. Okay, and that's a fun one. With your glasses, your general idea is that if you are nearsighted, you're hoping for being able to see to infinity. Okay, and 1 over infinity is the same as 0. Okay, for nearsighted, that would be 1 over infinity, which is 0. 1 over infinity equals 0. Mental note there. And if you are farsighted, those are the people that hold it really far away to be able to read. They would rather read it up close, and so that would be 25 centimeters or 0.25 meters for farsighted people. Okay, so those are some numbers there that you can use to be able to figure things out. So we're going to look at a couple of examples. These will go pretty fast too. Okay, we're going to use me as an example to be fun. All right, so Mrs. Gassler's glasses. My glasses have a power of negative 4.75. That's just in my bad eye. I have a good eye and a bad eye. My bad eye is my good eye is not very much better. It's like 4. And the question is, what's the focal length of my glasses? And are they for farsighted or for nearsighted? So we're going to be able to do both of those here. Okay, so power is 1 over the focal length. So I'm going to plug in negative 4.75. And we'll go 1 over the focal length here. So I'm going to be switching those numbers. So 1 over negative 4.75, and the focal length is negative 0.21. So I'm going to draw some arrows. The focal length will be 1 over negative 4.75, which is negative 0.21 meters, which is negative 21 centimeters. Okay. Now, that negative, when you have a negative focal length, that will tell you whether it's for farsighted or nearsighted, because negative focal length means that I have a diverging lens, which means that I am nearsighted. Okay, so that was fun. That's true, I'm nearsighted. I can't see anything far away, especially without my glasses. Now, here's the fun question. If I can see to infinity with them on, how far can I see without my glasses? This will be fun. Okay. All right, so we're going to take that second equation that we talked about here. The power of my lenses is 1 over DO with my glasses minus 1 over DO without my glasses. Okay. So with my glasses, remember, I can see to infinity. So my power is negative 4.7. I'm going to start over here. Negative 4.75. 1 over infinity, that's going to drop out of the equation. Minus 1 over the object, no glasses. Okay. So I've got 1 over 4.75 equals 1 over negative of that D object with my no glasses. So this is what I'm looking for. I'm trying to figure out how far I can see without my glasses. So, oh look, it's the same math that I did up there. So the object that I can see without my glasses, which is 1 over negative 4.75, is negative 21, negative 0.21, which is meters. So I can see without my glasses about 21 centimeters. I'm sorry, those negatives cancel out. Negative, negative. Okay. Get rid of the negative. There we go. All right, so I can see about 21 centimeters without my glasses, which is true, which is not very far. Here's a ruler. 21 centimeters is this, so this is how far I can see. Can you see all that? That's how far I might be able to see across the edge of a piece of paper without my glasses on, which is pretty true. That's why I can't find my glasses without my glasses on. It's funny. All right, so those are some examples there. If you have any other questions about glasses or calculations that can be done with glasses, let me know. Thanks for watching.